Hey guys, this is a new unit that we are starting this week. So I wanted to talk to you about some of the problems that you'll be looking at this week, some of the things you'll be learning. So we're going to start our statistics unit, so dealing with data. If you ask a statistical question, there's certain characteristics that statistical questions have. So that's kind of where we're starting. The screen says statistical data helps you draw inferences or conclusions about the characteristics of a population. So if someone is gathering data, they're trying to make an assumption or a prediction about a certain group of people's behavior. They want to see, for example, I think I have a good example right here. For example, grocery stores will use statistics to learn about the characteristics or habits of their shoppers. So grocery stores know the time of day when most people, the largest group of people will be in their grocery store at one time. They will find out where, when people are shopping, where do their eyes go? If they're going to buy cereal, are they going to buy the cereal that's in the middle of the aisle level, or are they going to reach up and grab the cereal on the top shelf or the bottom shelf? Where will their eyes go? Where will they spend their most time in a grocery store? If they're at the checkout, what is a product we could place up there that people will grab and buy on their way out? And that's why, the gum is up there, candy's up there. It's cheap. Everyone loves gum, everyone loves candy, and people will grab stuff like that. Water bottles are close to the checkout area just because people go, oh, okay, well, there's a bottle of Coke. I need to get one of those while I drive home. So everything about a grocery store is set up on purpose. The information was gathered through data, through statistics, and no matter where you go, people are always trying to gather data and figure out what people's shopping habits are. Okay, and of course, not just grocery stores, but any kind of shopping experience. So when you are trying to gather statistical data, it's a 4-step process. First thing you want to do is you're going to formulate a question that can be answered by data. You're going to design and implement a plan that collects the appropriate data. You're going to analyze the data using different types of graphs. Finally, you're going to interpret and compare the data. All right, so when you want to form an opinion, or if you are going to guess the characteristics of a certain population, one way to figure out if your guess or your hypothesis is correct is by going through the process of conducting the survey, looking at the results, charting it, seeing what patterns emerge. Now, when you come up with a statistical question, it must include a specific population that you're studying. So if I want to find out about the middle schoolers at Davis Middle School, I am looking for some sort of information, some specific information. I want to know, what do the students at Davis Middle School, how much time do they spend on the weekends reading? How much time do they spend during the week playing video games? How much time do they spend on their cell phones? We can compare their grade point average. How high are their test scores? And I want to see if there's a correlation between how much time they spend on their cell phone and how high their test scores are, right? So that would be information I would find out through statistical, gathering statistical information. So first of all, it has to deal with a certain population. Secondly, the answers, or when you ask a question, you have to ask a question that will get a lot of different responses from people you're asking. So in other words, you're not allowed to ask yes or no questions. You shouldn't ask questions that have exactly one answer. Like if I said, okay, well, I know there's 2 6th grade math teachers. I'm going to go ask the students, who do you get your math lessons from? Well, that's not going to be the data is not going to be varied, right? That is not a good statistical question. There's only 1 or 2 right answers. So you have to make sure when you pose a question, There are a lot of different responses. Finally, you must ask a question that it has a quantitative response. In other words, a number. So if I ask you a question, if I asked you, what's your favorite pizza topping? Well, that's a different type of survey question than gathering statistical data, because statistical data, your response needs to be a question, a number, like, how many times a month does your family order pizza? That's a good question. I could ask families from Davis Middle School, how many times a month does your family order pizza? That's a statistical question. So good questions like beginning questions would start with how many, how often, how much, how frequently, what percentage. So those are good ways to start statistical questions. All right, in order to gather valid data, there's a few things you have to keep in mind. Your question must be unbiased. So for example, if I said, how much time do you spend on your cell phone at night? Do you waste your time by spending 3 hours a night on your cell phone? Or are you a smart user of your cell phone and you use less than half an hour? So my question, first of all, you would have to answer with a question, you would have to answer with a number, but my question is biased, right? I am letting you know, I think if you spend more than 2 or 3 hours on your cell phone, then you're a time waster, right? So that's about a biased question. Don't use words that influence the person that you're asking. Your answers must be varied. In other words, a lot of different answers can be gathered, and clear. Don't ask yes or no questions. Don't ask questions that people have to guess their answers. For example, I wouldn't say, how many times did you watch SpongeBob back in 2010? A lot of people would say, I have no idea. I would have to guess the answer. That would not be a good question to ask. Your survey must be random. So if I was trying to gather information about people's favorite sports team or sport, I wouldn't go to right outside a basketball court and ask people, hey, what's your favorite sport? Or how much time do you spend a week playing so-and-so sports? I would make sure that my location wouldn't be influenced. It wouldn't influence the type of person I asked. So obviously if I'm at a basketball game, I'm probably around a lot of basketball fans, right? Oh, that's what my example was. Don't stand in a basketball game and ask people their favorite sport. And the survey must describe a population. Don't ask one person a question and call that a survey. That is not going to be enough data. All right, so when we look at distribution of data, the chart on the left is what we call symmetric, right? So we have a good, nice, what we call a bell curve. So the sides are low, the top, that's our peak, and the data is very symmetric. However, the one on the right, this is a dot plot. We've asked a question. We could ask, how many animals do you have? Or I don't know, how many siblings do you have? This would be a crazy answer if that was my question. But we see that on the one on the right, all of our data is very close together down here on the left. But then we have two outliers way out here to the right. So we would say that this data is skewed right. Because if I drew a pattern around these dots, it would, like a tail would go off to the right. So we would say that that is skewed right. So if you wanted to talk about the average or the median of the data, so the mean is when you get the data, you add up all the numbers and you divide by how many there are, right? So if we wanted to describe on average, how many brothers and sisters do people have? Well, this graph on the left, I would definitely want to use the mean because the data is so symmetric. However, out here on the right, when I list all those numbers from least to greatest, I would want to use the median of the data to describe the center of my data, because there are two outliers out here. These two numbers are far away from the rest of the data. So if I use the mean, it would look like people have a lot more siblings than most of them do because of these two high numbers. All right, now the range is the difference between the smallest and the biggest numbers. So that also tells you how spread out your data is. So really, if you have a smaller range, that means your data is much more condensed. If you have a large range, that means your data is much more spread out, okay? So if we wanted to find the range of this one on the left, it would be 4 minus 0 is 4. So the range, so between the smallest number and the biggest number, there's a difference of 4. However, the one on the right, if I wanted to find the range, I would say the range is 14 minus 0, which is 14. So that's a bigger range because the data is so much more spread out than the one on the left. And then we did talk about the shape. The one on the left is very symmetric. It has a bell shape, what we call a bell shape. The data on the right, we would say it's skewed right. All right, now when we're going to find the measures of center and the measures of spread, the measures of center are either two things, either the mean or the median. And you're going to use both of them depending on if there's an outlier present. If there's not an outlier, you're going to use the mean. If there is an outlier, you're going to use the median. And then we talk about how spread out our data is. We're going to use the range, which is what we just found. We subtract the smallest from the biggest number. Tells us how much difference there is between the smallest and biggest numbers, and also the mean absolute deviation, which I'm going to show you how to find the mean absolute deviation. All right, so let's do that. So first of all, if you're going to find, anytime you find the median, especially, you have to write these numbers in order from least to greatest. If you just go pick out the middle number the way they're written, that's not really the median. That's just how this data was written. But we have to rewrite these from smallest to biggest. So I have 20, 30, 24. So I'm going to mark these off, 20, 30. Uh-oh, I don't know how to order numbers, do I? Obviously, 24 is smaller than 30. 20, 24, 25. I missed two of them, didn't I? 30. And then I have 70, 95, 96, and 100. So this data is very spread out, isn't it? So I had 1, 2, 3, 4, 5, 6, 7, 8 numbers, and I wrote down 8 numbers. You always count when you're finished. All right, so now I'm going to, since there's 8 numbers, I'm going to do the mean first. I'm going to find the mean. I'm going to add up all the numbers and divide by how many there are. So on my little calculator, I'm adding 20 plus 24 plus 25 plus 30 plus 70 plus 95, 96, and 100. So I got 460. So I got 460 divided by, what do we say, 8? 1, 2, 3, 4, 5, 6, 7, 8. So the median is 57 point, I'm sorry, not the median. The mean is 57.5. 57.5. All right, now the median, if there was an odd set of data, there would be exactly one middle number. But since there's an even set, we actually have 2 numbers that are in the middle, so 30 and 70. So in this case, we would find the average of 30 and 70. So 30 plus 70 is 100, and 100 divided by 2 is 50. So the median is 50. And the mean is 57.5. Now, I wouldn't consider that we have an outlier. We have 4 pretty small numbers that are close together, and we have 4 big numbers that are kind of close together. So we wouldn't say that there's one number that's far away from the rest of the data, right? So if I was going to describe the center of this data, I would use the mean, 57.5. Now the range is the difference between the smallest and the largest number. So we would say the range is 80. So whatever these numbers represent, let's say they're test scores. So this person's test scores ranges by 80 points, the lowest and the highest test score. That's a big range, isn't it? Now, the last one we're going to do is find the mean absolute deviation. So remember, the absolute value is always positive. Well, when we find the difference between each data set and the mean, we're always going to use a positive difference. So I like to kind of make myself a little chart. So what you're going to do is you're taking each of the data points and you're subtracting it from the mean. Well, the mean is 57.5, and we always want a positive difference, okay? So for the first one, I'm subtracting 57.5 and 20, and I get a difference of 37.5. 57.5 minus 24 is 33.5. That would be 32.5. 30 would be 27.5. 70 minus 57.5 is 12.5. Once again, we're just using positive differences. 95 minus 57.5 is 37.5. This would be 38.5. And this would be 42.5, I think. Let me just double check that. 57.5. Yep, 42.5. All right, did I get it right? I think so. So now we found the difference in each data set and the mean. That's what it says. Find the average distance each data set is from the mean. So now what we're going to do, once we found our mean, step 2, you find the difference between every data set and the mean. And step 3, you find the average of the differences. Now we're finding the average of these numbers, finding the average or the mean of these numbers. So we're going to add up all these numbers and we're going to divide by 8 because there's 8 of them. So 37.5 plus 33.5 plus 32.5 plus 27.5 plus 12.5 plus 37.5 plus 38.5 plus 42.5 divided by, I got 262 divided by 8 is 32.75. All right, so the mean absolute deviation is 32.75. So what does that mean? It means on average, if these are test scores, on average, every test score is about 32 points from the mean. That means my data is very spread out. Now think about it. If I had test scores that were, I don't know, let's say I had 8 test scores and those scores were 52, 52, 54, 55, 56, 56, 60, and 60. And I found the average, it might still be very close to 57.5. I just made those numbers up. It wouldn't be exactly, but it'd be very close. And then if I found the mean absolute deviation and my lowest grade was 52 and my biggest number was 62, and I found the mean absolute deviation, I can promise you that mean absolute deviation would be very small compared to this one. So this is a big mean absolute deviation, and that just means that my data is very spread out. The smaller the mean absolute deviation is, the less spread out or less varied your data is. That's what that means. Okie doke. All right, so that's basically what I wanted to show you. So for your first couple of lessons, you're going to talk about what makes a statistical question. You're going to look at examples of statistical questions, and then you're going to talk about different types of data, which are mean, median, and mean absolute deviation. And then on Friday, you guys have a worksheet where you're practicing finding the mean absolute deviation. It's pretty self-explanatory, but of course, if you need help and you don't understand the directions, I will be happy to help you with that. All right, you guys. Well, you have a great week and let me know if you need me and I'll be here for you. See you later.